Hello students, welcome back once again. Continuation in the previous lecture, we will discuss Euler's deduction formula in this lecture along with the homogeneous function. In the previous lecture, if you remember, we have done discussion that what is a homogeneous function and how Euler's theorem by using homogeneous function we can find some kind of particular expression related to the partial differentiation. So in the same series, just continuing the same, today we are going to discuss Euler's deduction formulas. Now basically students, if I am talking about what is the Euler's deduction formula. So Euler's deduction formula or Euler's deduction theorem. Euler's deduction formula. If you remember what is Euler's formula, it is applicable for a homogeneous function. Now the thing is that it's not every time that the function is homogeneous. So the thing is that if function is not homogeneous and can be converted into homogeneous function by some of the adjustment or substitution in the function, then we can use Euler's deduction formula. Means what? What it says that? It says that if z, which is a function of x, y, z is not a homogeneous function, is not a homogeneous function, but fz, be a homogeneous function, be a homogeneous function which is formulated on the basis of the given z. If z is not a homogeneous function but fz be a homogeneous function, then according to this much it says that x into del z over del x plus y into del z over del y is equals to n into fz over f dash z. What is n here? N is the degree of fz. Because fz is a homogeneous function, so it should have a degree, and that will be the n. This is known as the first deduction formula. The second one, it says that x square del 2z over del x square plus 2xy del 2z over del y del x del y, sorry, plus y square into del 2z over del y square is equals to gz into g dash z minus 1. These two are known as the Euler's deduction formulas, students. What is gz where? Where gz is the result which obtained in the first one, that is n into fz upon f dash z. If you remember, the left side is the same as we have done in Euler's formula, but that is for the homogeneous function. If the function is non-homogeneous, but it can be make homogeneous. Try to understand the difference. The difference is what, students? Euler's formula is applicable for homogeneous function, but deduction formula is applicable for what? Deduction formula is applicable when function is not homogeneous but can be converted into homogeneous. It's not that for every non-homogeneous function we can apply the deduction formula. The thing is that not homogeneous, the function is not homogeneous but can be converted into homogeneous by some of the substitution. If we want, we can do the proof of this result also in the same manner as we have done for Euler's formula. That is, if I just consider that fz as z, and we will get the fz as z means the given function, and we will get the result over here. I am not going into the proof. I am just explaining how we can apply this formula in some particular kind of questions. I hope you understood the concept. Two things we need to remember. The first thing is what? The function is not homogeneous. Second thing, function can be make homogeneous by some of the adjustment or some of the substitution. Let us see how. I am taking a function. Let z is equals to cos inverse x cube plus y cube upon x square plus y square. This is what, students, we are having a given function and the question is asking the same result. Now we need same result means the same as the deduction formula we are having. Means the question is asking in the first part x into del z over del x plus y into del z over del y equals to how much? In the second one, they are asking x square into del 2z over del x square plus 2xy into del 2z over del x del y plus y square into del 2z over del y square. Now, if the function is homogeneous, the first result will be n times z and the second result will be n into n minus 1 times z. So we need to check whether it is directly homogeneous or not. Let us see. I am just trying to reduce it into the standard form. What is the standard form of homogeneous function? Either it should be written as x power n into function of y over x or y power n into function of x over y. The function should be reduced either these two forms, then it is said to be a homogeneous function of degree n. So let us try to do it. I am taking x square common from the numerator. So 1 plus y upon x whole square upon x cube should be taken common because its highest power of x is 3. Remember, we need to take the highest power either for x or for y. It's totally your choice. So this got cancelled, which is equals to how much? Cos inverse of x into the rest of the term can be written as function of y upon x because they are having the term of y upon x. Now, the thing is that, students, can I say this is in the first standard form? No, I cannot say because x power n is outside and rest of the function is inside. Means I can say it is homogeneous if I can take this x as outside. That is, if I can write x into cos inverse function of y over x, which will again a function of y over x. That is x into function of y over x. Then it will be a homogeneous function. Then it will be a homogeneous function of degree 1 because it is reduced in case number 1. But the thing is that the step that I done, they are correct or not? What I am doing, I am just taking x outside the function. It means what? If somewhere is written sin x, can I write it as x into sin? Is it right to write this expression? It is correct to write it? No. Obviously, it's no. We cannot do this thing. So the same thing is that x cannot take an outside over here. So this term cannot be equal to these two terms, and hence this function is not homogeneous. This function is what? Not homogeneous. And why it is not homogeneous? Due to this special function which is outside x into function of y upon x. That is, if this cos inverse will not be there, this cos inverse can be removed, then the rest of the function is absolute homogeneous function of degree 1. No concern or no issue for that, I think. Now, function is not homogeneous, so Euler's formula cannot be applicable on it. What should we do? Deduction formula. Now in deduction, I have to construct some fz which make the given function as homogeneous. Just pay attention on it. Cos inverse, just creating the problem. If I take cos inverse on this side, means what? It will be what? If I taking on this side, it will be cos u. Then there is no problem for the homogeneous condition. Means z is not homogeneous. Sorry, z is not homogeneous, but cos z is a homogeneous function. I hope you understood the concept. Once again, z is not homogeneous function, obvious. But if I take cos on the left side, I get cos z. That will be the homogeneous function. Na? Z is not homogeneous, but cos z is homogeneous. And this is the condition for deduction one, na? Deduction formula. That function is not homogeneous, but by some substitution, we can make it homogeneous. Means, here I am getting a result. Here, z is not homogeneous. Here, z is not homogeneous function, but cos z is homogeneous. Cos z is homogeneous of degree. What is the degree? Degree 1. Because if I am taking cos on this side, it will be x power 1 into function of y over x. And this is the same we are having the result of deduction formula. Just see, fz is not homogeneous. Z is not homogeneous, but fz is a homogeneous function. Then this result is applicable. It means what is our fz over here? This will be the fz that we should have. This will be the fz that we must have. Z is not homogeneous and fz is homogeneous. So in the problem, fz will be how much? Cos z. This is very important, student, how to identify fz or f of u. Simply, what should we do? Analyze or try to convert the function either in this form or in this form. If yes, apply the Euler's formula. If not, try to construct a new function fz which will be the homogeneous one. Then we can apply the deduction formula. And how to construct fz? Simply whatever spatial function is there outside in the function, we have to remove that function. Like in case of cos inverse, cos z will be fz. Suppose that it is sine inverse, fz will be sine z. Suppose that it will be log. If here I am having log, then fz will be what? E power z. Means we should take the anti-function of this function. Fz should be taken anti-function of this function. And we will get the value of fz. Then we can apply the deduction formula and we'll get the result. So according to deduction formula, this will equals to how much? This will equals to n into the first one, n into fz upon f dash z. N into fz upon f dash z. What is n over here? 1. Fz cos z over differentiation of cos z for z is what? Minus of sin z. I hope you know the differentiation of sin z is cos z. Cos z is minus sin z, which will be minus of 10 times z. So the result of the first expression is what, students? Minus 10 z. The result of first one is what? Minus of 10 z. The result of second one, if you remember, it is gz into g dash z minus 1. And what will be gz? The result of the first expression, where gz is minus of tan of z. Put it over here, we will get the result of the second one. That is, it will be equal to what? Tan z with minus sign. The derivative of tan z is how much? Sec square minus 1. So this is what, students, we are getting the result gz into g dash z minus 1. So this is how we can use the deduction formula. I hope you understood the concept. Only the thing you need to focus that identify whether we should apply the deduction formula or original Euler's formula. If the function is homogeneous, you can apply a direct Euler formula. If not homogeneous but can be converted into homogeneous, then deduction formula. Remember, I am not saying every non-homogeneous function, for every non-homogeneous function we can apply deduction formula. No, I am not saying this. I am saying if the function is non-homogeneous, but it can be converted into homogeneous. Then we should apply the deduction formula. Let us see one more example so that the concept will be more clear to you. If u equals to log of x power 4 plus y power 4 upon x plus y. And the question is asking find the value of x into del u over del x plus y into del u over del y. And also the second part means I am finding both the part for the same. X square del 2u over del x square plus y square del 2u over del y square plus 2xy into del 2u over del x del y. So now you can see there is a special function outside. There is a special function outside. So the function directly will not be homogeneous. Not homogeneous. So we should construct a new function. Let f of u equals to what? Anti-function for log e to the power u. And it will be homogeneous. We can check it. E to the power log of x power 4 plus y power 4 upon x plus y. We are having a result. E power log x is x, which is x power 4 plus y power 4 upon x plus y. And I hope you remember the concept of the first class. I told you numerator is individual a homogeneous function of degree 4. Denominator is also individually a homogeneous function of degree 1. So this is what? A homogeneous function of degree how much? Degree of numerator minus denominator, that is 3. So u is not a homogeneous function, but e to the power u is a homogeneous function of degree 3. So this will be what? N times f of u upon f dash u, which is what? 3 times fu is e to the power u. Its differentiation is also e to the power u. So it will be how much? 3. For the second one, it is gz into g dash z minus 1. G dash is what? The result of the first statement. So gz is 3 over here. So 3 into derivative of 3 is 0 minus 1, which is what? Minus of 3. So for this question, the first part is what? 3 and the second part is what? Minus of 3. Now I hope you understood that how we should identify that deduction formula is applicable or Euler's formula is applicable, and after identifying that, how to get the required result. Moreover, this is only applicable when the question is asking these two expressions, either first or second or both of them. One more question. If u equals to x square tan inverse y upon x minus y square tan inverse x upon y, then the question is asking find x into ux plus y into uy. Ux means partial derivative of u for x, uy means partial derivative of u for y. Now, first of all, you should identify that whether we should use deduction formula or we should use original Euler's formula. Now you can see this is the standard form of homogeneous function and its degree is how much? 2. It is also a standard form of homogeneous function. Its degree is how much? 2. The function is having two terms and both of them is of degree 2. It means what? The given function is homogeneous of degree 2. Homogeneous function of degree 2. So we should not apply the deduction formula over here. Remember, we should not apply the deduction formula over here. Directly by Euler formula, it should be n into u. N is 2, that is the degree. So 2 times u is the result for this question. Even if you are applying the concept of partial differentiation on it and solving by the long process or descriptive one, it will take too much time. Now by using the concept, you are getting the answer within the quick possible time. I hope you understood the concept that how we can apply the deduction formula. And that's all from my side, students, for this lecture. Hope you understand the concept. Thank you. Thank you very much for your attention.